Dear students, now we shall learn about yet another important and interesting combinatorial circuit, which is called the decoder. So what is the basic function of a decoder? A decoder takes a n bit input and gives a 2 to the power n bit output. What does that mean and how does it function? Let's see. So you have a 1 bit decoder. So the input to this decoder is a single bit, and based on this bit the particular port gets activated. For example, since this input is 1 bit, the output will have 2 to the power 1, that is 2 output ports. If the input is 0, then the port 0 gets high or activated. If the input is 1, the port 1 gets activated, as you can see. Now let's suppose I want to create a bigger decoder. Okay, so when I create a bigger decoder, you will be able to understand the example better. So I first choose the decoder over here, and you can see the properties. Now I choose the bit width as 2. The moment I choose the bit width as 2, the input port becomes a 2 bit and the output port becomes 4 bit, because 2 to the power 2 is 4. Now I also need to convert this input into 2 bits. So what shall I do? I shall click on this toggle option, toggle bit, and choose the bit width over here to 2. Now let's connect it with the input, and corresponding to all the outputs I connect the LEDs. So you see that a 2-bit input can actually take 4 possible values, and that particular value has a decimal representation. Let's say 01. 01 is 1 in the decimal system, so that particular port becomes high or 1, and rest of them becomes 0. So this is often used in the design of circuits where you have to choose among multiple options. So you see, when it's 00, the decimal equivalent is 0, so port 0 gets high and the remaining 3 remain low. If I want to choose 1, then I select 01 and the port 1 gets activated. Similarly, if I want to choose 2, which in decimal form is in binary form is 10, you see this port 2 gets activated. And finally, for activating port 3, I choose 11, which is the binary form of 3, and you can see port 3 gets activated. Similarly, if you want to create higher number of bits, then you can choose the value over here. As you can see, a 4-bit input requires a 4-bit, and decoder will require a 4-bit input over here, and you will get the output to be 2 to the power 4, that is 16. So you see, I am drawing all the lines out here, and you can see the bit values when I click on them. So when it's all zeros, that's a single 0, the 0th port remains 1 and rest everything becomes 0, which is represented by dark green color. Now let's say I want to choose 10. What is port 10 in the binary system? That will be 0, 1, 1. Sorry, 10 is 8 plus 2. So 2 is this bit and 8 is this bit. So 8 plus 2 is 10. So you see port 10 has been activated. Similarly, if I want to choose port 6, so port 6 can be written in terms of powers of 2 as 4 plus 2. So I choose 2 from here and 4 from here. 4 plus 2 equals to 6. So port 6 becomes active. So this decoder circuit can be used for designing very complex or advanced circuits in your future lecture courses in digital systems.